Hi
Hello.
friends, good evening.
Good evening.
So welcome to the domain analytics training by 360DigiTMG. So we are discussing about forensic analytics. So previous classes we discussed about applications of forensic analytics, where these forensic analytics are helpful to investigate. Especially we investigate the cases, and we can collect the evidences, and we can compare. We can make that evidence into some proofs and etc. that we will submit in the court hearings and etc. So these are the main applications of forensic analytics. And after we discussed about CRISP-MLQ methodology, cross-industry business standards for developing machine learning applications with quality assurance. So in CRISP-MLQ, so we have 6 phases starting from business and data understanding. So where we need to understand the business problem and we will understand the data. So this first analytics is application. Suppose if there is any problem statement, if there is any business problem related to forensic. So not only forensic, any machine learning problem. So first we need to understand the business problem. So after we need to know, so what should be the business objectives and business constraint. So the business objectives are nothing but the measurable things which will help to which are required to improve the business. So what steps we need to take to reach our target? We can say like business object. So coming to business constraint, that are nothing but limitations. So after understanding the business problem, then we need to understand the data. So after understanding the data, so next step is nothing but data engineering. So data engineering is nothing but we will do 2 things, EDA and also pre-processing. So EDA nothing but graphical representation of various things. So to understand, to get the idea regarding the data set, and after EDA will give some information. So regarding it, how about our data set? So do we have any outliers in our data set? And do we have any NA values? It's because before going to the model building state, so data should be clean. So then only we can able to analyze the data. So after that, yeah, if data is clean, we will go to the model building step. So in the model building, we will test it. So we will test our we will test our data set with various models. We have supervised and unsupervised. We will try with various machine learning algorithm, and we will finalize which will give more accuracy. So after building the model, we need to deploy. So that our model should be deployed in the production environment. So where, so if you deploy, then our model ready to predict the future values. So finally, there will be a next step, quality assurance. As after building the model, after deploying, when we are using the model, gradually the performance of the model will decrease. That leads to staleness. So to overcome that, we will need to retrain the model if required. So these 6 steps we will follow to develop machine learning applications. Yes. So after we discussed about clearly EDA and pre-processing with hands-on example, then we discuss regarding unsupervised learning. Nothing but K means clustering. So clustering is nothing but splitting the data into the various groups. So clustering we use more in forensic analytics. We'll use more clustering concept. So example. So clustering is nothing but if we have the historical data. So based on the patterns, it will give rules or patterns. So that will helpful to that prediction. That rules or predictions will helpful for predicting the new value. Even if you don't know about the output, we can give the rules. So in the same way, forensic analytics, so we may solve the forensic analytic experts will solve various cases. So after solving that case, they will store this evidence. So they will store this evidence. Now they can compare this evidence with the features what they are facing present. Suppose the person has going to investigate one case. Need to compare any such cases did we face. So any same. So if you know, so say such type of case. Suppose I have seen crime scene. I have noticed, I have collected some evidence. So this evidence is nearer to the some incident happened some years ago. So what I will do, what procedure I followed, same I can implement to get the solution or to follow up to collect the evidence. I will submit that evidence in the court, etc. So that process will be involved. So in this way, K means clustering. So it is unsupervised learning. So unsupervised learning means there is no output variable. We will predict, just it will give patterns or rules. So after we discussed about supervisor learning, there we have output variable. So if our output variable is a categorical, then we can use a classification model. So last two classes we discussed about the classification model, KNN and also decision tree. So KNN is nothing but K nearest neighbor. So K nearest neighbor nothing but if I know about your neighbors, I can predict about. So we discussed one use case. So we can classify a particular place, whether the place is it violence or non-violent place. So based on some neighbors, so based on some conditions, so that we discussed it clearly. And after a decision tree, so decision tree we can use it for a classification problem as well as regression. So yesterday we discussed about shooting. So what are the types of what we can classify. So based on the classification, we can take suitable measures. So these are the things we have discussed up to now. So today we are here to discuss about linear regression. So regression, it is a supervised machine learning model, and where if the output variable is continuous, just we'll go with the regression. Now in the regression, we are discussing linear regression. So linear regression is a machine learning algorithm. So it is based on supervised learning. So it performs a regression task. And I can say a simple straight line expression. Suppose y is equal to mx plus c. So in y is equal to mx plus c. So this regression will give the relationship between independent variable and also dependent variable. So the dependent variable is, I can write here. So dependent variable is y. So independent is equal to x. So we have two types of regression normally, simple linear regression and multiple linear regression. So simple linear regression, if our independent and dependent variable, if dependent variable is 1, so then we nothing but that is simple linear regression. If we are going to analyze the relationship between more than dependent variable and more than one independent variables, like 3 or 4 independent variable with respect to 1, that is comes under multiple linear regression. If you see, so this is the equation of the straight line. That line which is passing to the origin is nothing but regression. Now right side you can see the regression equation, beta naught plus beta 1 xi plus. So this is a simple regression equation. So if more independent variable, then we can write y is equal to beta naught plus beta 1 x1 plus beta 2 x2 beta 3 x3 and so on. If only one independent variable, nothing but y is equal to mx plus. So this is a scatter plot. It provides the graphical representation of relation between the two continuous variable. Now, let us discuss how the regression will be helpful in forensic analytics. See, there will be a lot of examples to understand regression concept in forensic analytics. First one is, what is the reason of that incidents? So what factors are affecting on that incidents? So there will be various places, various number of incidents are happening. So if you consider the incident is nothing but a Y, so the factors what are affecting on that incidents, so we need to compare so that we will reduce. So if you know the reasons, then definitely we will solve. So in this way, we can reduce the crime rate in a particular location. So what will be the possible reasons for such type of things are happening? We will reduce. So that is the first use. And second thing is, in any way, our team, forensic team, will collect the evidence. So while collecting the evidence, so they can notice the person who is the responsible such type of crime. So his age, okay, his age, his color, some information we can predict based on regression. So these are the main usage of regression in forensic analytics. Now let us understand more by doing hands-on. So here you can have one problem statement. So the problem statement based on the data set containing crime rate. So our data set is consisting of crime rates by metropolitan cities 2016. So the project aims to predict the violence crime rate in metropolitan cities. So we have the data set containing the crime rates in metropolitan areas. So the project aims to predict the violence crime rate in that particular areas. First, anyway, we need to import the libraries. So pandas for understanding, for doing analysis, for handling the data frame, and numpy for arrays, matplotlib.pyplot for visualization, cbound for visualization. Just let us run this. Yes, successfully we have executed. Now loading the data set. So if you want to load the data set, I have this file, crime rates by metropolitan areas. So this Excel file I have already in my Jupyter. So what I will do, just I can execute this. Yeah, done. So what, successfully I have loaded the data set. Now what is, I want to see my data. So data dot head will show. So first 5 rows. So these are the first 5. And similarly, if you want to see the last 5 observations, so you need to execute this. Fine. So what are the various columns are present in my data? So I want to know. So data dot column. So the columns what I have. So metropolitan statistical area, places in light type, are part of bigger metro areas in bold. Yeah. So here the column length, the column names. So length is more. So what I want to do, just I want to rename the column names. So to rename the column names, I can use the command data.rename. So columns is equal to, so metropolitan statistical area, places in light type of parts of bigger metro areas in bold. So this total I can simply make as metro station name. Similarly, violence or and crime. I'm renaming with violence underscore crime underscore. So murder or some again, so I can with the name. So harassment. So these are the various types of crimes. So that names I have changed it. Now once if you execute, it is done. Now let us see the shape of the data. So our data set consisting of 2,800 2,895 rows and 12 columns. So compared to previous use cases, so this data somewhat size of the data is some less. Right. Now display the variable names and the data types. So data types will give the information of the data type of a particular column. So metro station, population, violence, crime rate, murder. So harassment, just I want to make a horse robbery. So these are the various crimes. Now, just I want to perform descriptive statistics. So to perform descriptive statistics, we need to pass this command data.describe. Now data.describe. So discrimination is performed on all the columns or in our data set. So starting with count, mean, standard deviation, min 25th percentile, 50%, 75, and also max. So these are things up to EDA. So exploratory data analysis is finished. Now, so let us understand what is data pre-processing. So data pre-processing is nothing but in our data set, if there will be any values or there will be outliers. So we need to rectify that so that our model will work fine. The first thing is check the missing values. So if you want to check the missing values in our data set, we need to pass the command data.isNaSum. So isNaSum will give. So if you have any NA values in your column, the sum of the total in how many NA values are there in a particular column. So we will. So just let us run this. Yes, you have NA values maximum all the columns. Now we need to handle the NA values. So dropping the unwanted columns first. So data drop. So columns is to note that not all areas show violent crime totals. So I'm as my feeling. So this column will not give more information. So it is not important for our analysis. So that's why I want to remove this. So if you want to drop a column, you need to use the command data.drop. And access is equal to 1, nothing but column. Now, one more unwanted column I notice. So that unwanted column is nothing but population. Yeah. So anyway, so our data set size is around 2000. So drop NA. Suppose if you use the drop NA as per the value, approximately 900 or 1000 rows will be deleted. Suppose it leads to loss of data. So this is not a good thing. So in that case, what I want to do is I don't want to drop my data. So I want to use imputation technique. So I am performing the mean imputation to fill the NA values. All NA values are filled by the mean of that particular columns. Now performing mean imputation to fill the null values. So first column, violence crime rate. Done. Similarly, I want to perform mean imputation to the murder. Similarly, I want to do for harassment. Next, performing mean imputation to fill the NA values, robbery. Next, property crimes, same. Performing the imputation, burglary, theft, motor theft. These are the various crimes. Yeah. So I have performed on a cell. Now I am checking. So after performing the imputation, just I am checking. So metro station name. So there will be NA values. Okay, we will go. Fine. Now, what are the data columns? So data columns are metro station name, violence, crime rate, murder, harassment, robbery, assault, property crime, burglary, theft. So these are the various types of crime. Now, for my consideration, so I am selecting the some features, so which are important to predict the output value. So I want to select the input variable, the independent variables for our output. So here I selected murder, harassment, robbery, property crime. So burglary. So it is burglary is nothing but so illegal entry of a building with intent to commit a crime. So just it is one type of crime, illegal entry to commit a crime. Motor theft. Now, how my output? I want to predict the violence. So which type of violence, crime, right? So with respect to these things, how the crime rate is increasing and how the crime rate, violence crime rate is affecting. So with respect to these all features, murder, horse nothing but harassment, robbery, property crime, burglary, motor. Just I want to run this. That is fine. Now I want to see head. Only these features I want to consider. So I'm going to apply multi-linear regression. So because regression is nothing but relationship between dependent variable and independent variable or variables. Now simple linear regression, if we use simple linear regression only if we have only one independent variable, one dependent variable. But here I want to consider more independent variables. So I can use multi-linear regression. So this is our data set. This I want to consider. So X are nothing but this value: murder, harassment, robbery, property, crime, burglary, motor theft. So Y I can execute. So what is Y? So Y is the target output variable. So the output variable is nothing but violence crime rate. So successfully we have finished data engineering step. So data engineering is nothing but exploratory data analysis and data pre-processing. Next, coming to the model building. So I'm using multi-linear regression. So to implement model building, just we need to execute from sklearn it will provide so various packages for our model building for. From sklearn.model selection, import train test split. So anyway, we will not do analysis on total data, just 80% train and 20% on test. So this will split our data into 80 and 20. Now we are using standard scaler, scaling our data for analysis, easy analysis. Now let us import from sklearn.linear model, import linear regression. It is important for our algorithm. Yeah, so multilinear is nothing but linear regression. Now multilinear dot fit X train and Y train. So next Y predict, multilinear predict and X test. Prediction on text, training. Now from sklearn.metrics, import R2 score. So mean squared error. So test accuracy, R2 score, Y test and Y predict. Just I want to secure. Yeah. So what is accuracy? So accuracy of the model is 0.71. Just I want to calculate RMSE. RMSE is nothing but root mean square error. So root mean square error value is 672. Okay. Somewhat better for model. Next. So train accuracy I want to calculate. Oh, sorry. So here this line I did not write. That's why you got this error. Yeah. Now let us run this. So what will be the accuracy of the model lost? So the accuracy of the model is nothing but 71%. So in this way, just by using multiple linear regression, so I have taken some features like murder, harassment, robbery, property crime, motor theft, etc. So these are all independent variable, and my output variable is nothing but violence crime rate. So now I have applied multiple linear regression for this data. So then I can predict. So I can predict so how the violence crime rate is changing with respect to this. So after having analysis, now the ultimate goal is how to decrease this crime rate. So what steps I need to follow? So what suitable measures I need to implement in that particular location to reduce that violence crime. So that I can get by using this data. So here we discussed up to model building, and as per CRISP MLQ methodology, just here this is only model building will finish, but it should be deployed. It should be the same model will be deployed in the production environment. So after deploying that model, then when we pass, so here each and every column having the values, integers. So it will ask what will be the sum. It will be percentage or some value. Now by passing the values, so what will be the crime rate? I can notice just by how the values are affecting that crime rate. So which values are making that crime rate is minimum. So I can implement that. It will predict and it will give some suggestions so that the police they can take responsibility to reduce that crime. So this is about the forensic analytics use case in multilinear regression. So once we can revise, so what we discussed up to now. So today we started linear regression. So linear regression is a supervised machine learning. So where we have the output. So machine, here we have the output variable, label data. Now in simple words, we can say linear regression is nothing but relationship between independent variables and dependent variables. Suppose if your independent variable is only one, then we use simple linear regression. So how one factor is changing with respect to another factor. And let us take, so in our hands-on example, we took some different columns and different independent variables, and finally we predicted. Now let us take general case. You can take sales and TV. So you can consider TV as independent variable. Sales is nothing but dependent variable. So sales are depending on TV. So which brand TVs? Mostly the people is going to purchase. So we can predict. So you may get linearly. If you want to compare only two independent variable and one dependent variable, then you can use simple linear regression. But if you have more variables, like if your independent variables are nothing but more than one, then we use multiple linear regression. So these are the examples of linear regression. So first one, you can compare it is a y is equal to mx plus c. Now, y formula of slope also given. It is delta y by delta x, and c is the thing about y-intercept. So if you have only one independent variable and one dependent variable, so here y is the thing with dependent variable. How the value of how x is changing, you can able to show here. Now suppose if you have more independent variable, then you can use yi beta naught plus beta 1 xi epsilon I. So we can apply this formula to, so y is equal to beta naught plus beta 1 x1 plus beta 2 x2 beta 3 x3 and so on. So this is a scatter plot, and how the regression is helpful in forensic analytics. Just we can compare. So based on if the forensic experts visited that crime scene, they will collect some samples, so they can give the relation. So how the samples are affecting that crime rate. So you can take one example. Some years ago, we have collected some sample. So based on that sample, it leads to one type of crime. Now, same samples if I found in the particular place, then definitely I can predict it is related to the crime, so which was happened some years ago. Now what happens, the investigative procedures will take less time. So instead of starting as a new case, so we can simply we can compare and we will solve the case as early as possible, and we can submit our evidence. Even the forensic team also generally they store the total data in the documents. Now they are storing the data in the databases. So there will be some particular databases. So no one have access for the databases. Only the responsible persons, the team who is going to solve that case, they may have access for the database. So, but here also there will be one challenge. So they need to search various documents. So until and unless they need to get the document which is related to their crime scene, which is going to solve. So that is anyway challenging. Even it is challenging, the forensic analytics, forensic science plays an important role nowadays, especially to solve the various cases and to produce the results in the court hearings and to take the necessary steps. So necessary steps to control that violence in the particular regions. Okay, so this is regression in forensic analytics. Yeah, we discussed it successfully. Last two classes comes under classification. So today we discussed about regression problem. And yeah, so tomorrow we will come with the neural network concept. Yeah, thank you for joining. So please subscribe our channel. Yeah, thank you. Have a nice day.